GUDID energy devices. What you see is a map of about 34,000 electrosurgical and advanced energy devices from the FDA's device registry, organized into 20 clusters. Curvo's language model read every product description and grouped them by the meaning it found. The largest regions are laparoscopic instruments, electrosurgical systems, and bipolar and monopolar shafts. Let's explore. Yasargil fenestrated forceps, 291 devices that form a tightly focused family. Yasargil bipolar forceps with fenestrated tips. Every device here shares the same insulated bayonet shaft, a design that allows surgeons to see tissue through the forceps jaws during coagulation. Tip widths from 0.4 to 1.5 millimeters, in lengths from 7.5 to nearly 12 inches. A small, specialized pocket connected only to its immediate neighbors. Yasargil stop pin forceps, 178 devices forming the purest single product line cluster on the map. Yasargil bayonet bipolar forceps with stop pins. Every device here follows the same template, insulated, non-stick, with tip widths from 0.4 to 2 millimeters and shaft lengths from 6 to nearly 10 inches. The stop pins distinguish these from the Yasargil irrigating and fenestrated variants in neighboring clusters. Microtine forceps, 200 devices of a specific long bayonet design with graduated tip widths from 0.4 to 1.5 millimeters. The microtine name distinguishes these from the Yasargil, Marley's, and Roten families nearby. Insulated shafts with non-stick tips in lengths up to nearly 12 inches, with angled tip options at 20, 30, and 45 degrees. The map's smallest forceps satellite. Ultrasonic and piezo tools. About 3,300 devices spanning two distinct worlds united by ultrasonic vibration. On one side, dental scalars, cavitron systems vibrating at 25 to 30 kHz to shatter calculus, PIEZON handpieces, and endodontic retreatment kits. On the other, piezosurgery bone scalpels and CUSA ultrasonic aspirators that cut bone with sub-millimeter precision for craniotomies and spinal surgery. Symmetry and SURGIX forceps. Over 3,500 instruments from the major forceps brands, Symmetry bipolars, SURGIX high-performance designs, Cushing bayonets, Hardy patterns, and ELMED connectors. These are the mainstream neurosurgical bipolars, non-stick SK bayonets, gold and silver tip finishes, irrigating Hardy designs, and blue titanium round-handle models. ELMED European bipolars. About 1,150 instruments with a distinctly European character, metric dimensions, US-pin and flat plug connectors, and precise German engineering from ELMED and KLS Martin. Roten and Marley's bayonet patterns dominate, with non-stick coatings and tip widths specified in tenths of a millimeter. Flat-handle neurosurgical. About 300 instruments spanning Yasargil, Roten, Marley's type, Scoville Greenwood, and Kiefin bipolar forceps, all written in a specification sheet format with working lengths to the 1/8 of an inch, handle type callouts, and material specifications. The flat handle and round handle designs in titanium and stainless steel share this formulaic description style, which is what pulled them together despite belonging to different surgeon eponym families. Marley's stainless forceps. 316 devices centered on Marley's pattern stainless steel insulated bayonets, the workhorse of open neurosurgery since Leonard Marley's refined bipolar coagulation in the 1960s. Tip widths from 1/4 to 1.5 millimeters, all with stop pins for depth control. The cluster also picks up radio frequency thermal lesion probes that share similar descriptive language about tip dimensions and insulation. Bipolar and monopolar shafts. Over 4,500 general-purpose bipolar and monopolar instruments, endomotors, Adson bipolars, METZ and BUM dissecting scissors, cup grasper inserts, and hand-activated monopolar forceps. This is the MAP's second-largest hub by PageRank, connecting strongly to the branded forceps cluster on one side and the laparoscopic world on the other. MIS kits and components. About 300 devices that are systems rather than individual instruments. Microglide MIS bipolar forceps in graduated lengths and tip widths, XACT robotics disposable kits, and Kia sleeve trocar systems for port access. The kit descriptions list energy instruments as components, trocars, clip appliers, retrieval systems, and insufflation needles packaged together. Surgical foot switches. 426 foot switches and pedals that surgeons use to activate electrosurgical generators without lifting their hands from the operative field. Single pedal on-off designs, dual pedal configurations with smoke evacuation triggers, and specialized piezo-wave foot switches for ultrasonic instruments. Positioned at the MAP's edge with only 16 bridge edges, a neat illustration of how language separates the tool from its controller. Electrosurgical systems. About 4,700 devices that represent the infrastructure side of electrosurgery, generators, video streaming applications, dispersive patient plates, neutral electrodes, and photon blade illuminated RF devices. Where adjacent clusters are dominated by handheld instruments, this one holds the systems that power and control them. CLAIS non-stick forceps. Nearly 1,200 devices dominated by CLAIS and CLAIS reverse non-stick forceps from KLS Martin, a German manufacturer whose formulaic product descriptions set them apart in embedding space. Bayonet profiles with flat plug and 2-pin connectors, tip widths from 0.3 to 2 millimeters. EEG and endoscopy electrodes. The MAP's smallest named cluster at just under 200 devices, combining two unrelated product families united by wire and electrode vocabulary. Double-color handle polypropylene snare devices for GI endoscopy sit alongside gold and silver disc EEG cup electrodes and chest belt EEG caps. Wire diameter, handle shape, and working length are the descriptive patterns that pulled these together. RF ablation probes. About 1,600 devices for thermal tissue ablation, microwave ablation needles, owl facet denervation systems, radio frequency generators, and sidekick curved probes. These are the tools of interventional radiology and pain management, using focused heat to destroy tumors or deaden nerves. Laparoscopic instruments. The MAP's largest cluster at over 8,000 devices for minimally invasive surgery. Maryland graspers, Liga Shore vessel sealers, J-plasma argon devices, BABCOCK inserts, curved scissors, and Handex monopolar hooks. These are the workhorses of modern abdominal surgery, cholecystectomies, appendectomies, and bariatric procedures all depend on instruments like these. Irrigating bipolar forceps. About 800 instruments anchored by Yasargil irrigating bipolar forceps, insulated bayonet shafts with non-stick tips, stop pins, and built-in irrigation channels that cool tissue during coagulation. Versa True disposables from Codman and Integra Jarrett specialty instruments also appear. Catheter and electrode pads. About 740 devices that form the MAP's most heterogeneous cluster. Defibrillator paddles, harness strap systems, and owl hybrid RF insulated cannulas, blunt, sharp, curved, and straight, in gauges from 18 to 22 and lengths from 50 to 150 millimeters. The common thread is patient connection, pads, cables, and interfaces between energy generators and the body. Gold and silver tip forceps. About 1900 devices distinguished by their premium tip finishes, gold and silver plated tips from brands like V. Mueller, Integra Ruggles Redmond, and others. Roten bayonets, Cushing straights, Scoville Greenwood irrigating designs, Hardy patterns, Semkin bipolars, and coaptation specialty forceps all appear here alongside electrode pads and sphincterotomes. Grasping forceps. 270 mechanical tissue graspers, Ali's patterns, alligator jaws, dolphin nose dissectors, fenestrated designs, and claw forceps, none of which deliver energy themselves. They appear in this energy device dataset because the FDA registry groups them alongside electrosurgical instruments, and their descriptions share enough laparoscopic vocabulary for the embedding model to pull them into the same neighborhood. And that completes our tour of the energy device landscape. From simple bipolar forceps to advanced energy platforms, from Yasargil's microneurosurgical legacy to laboratory coagulation controls that share only a word, this map reveals how language itself organizes a product catalog. Clusters that sit close together share deeper similarities, and the bridges between them trace the paths where one technology shades into the next.